So about 25 odd years ago, I just decided I would like to do that full time for myself. So I started HYDPOWER, and predominantly I had already been focusing on working with original equipment manufacturers around Australia.
Yeah.
And there was a real need in that industry. I think at the time we were working on much smaller machines, much smaller flow rates, and of course, as what happens in the Australian way,
Everything grows.
it grows and it gets bigger and bigger and bigger and more refined. And I think that natural progression is a good thing, and I think it's part of what makes Australia what it is. We set out about 5 years ago in designing a whole complete brand new wool press, and
it's called?
It's called Woolmaster.
Woolmaster.
So woolmaster.com.au.
Yep.
But it's the only Cat 3 compliant machine that meets the Australian safety standards.
Welcome everybody to the Seraph Machinery Podcast. I'm here today with founder of HYDPOWER, Shane Burke. Thanks very much for your time, Shane.
Good to be here, Rod.
Excellent, mate. Shane's been here with us today doing some training with some of our staff and going over some bits and pieces, because we've been using Shane's services for a long time now with our Ultisow product. Shane, would you like to start a little bit about your background in hydraulics and your business?
Yeah, okay. I started out as a young fellow. Actually, I wanted to be a pilot and I was going to join the Air Force, but I was also playing football and I got drafted to Richmond.
Oh, really?
Yeah. So I ended up, football become more important than my work. So so I pursued that, and then I thought, well, now I need a job. So I went for a job for sort of a bit of a joke, and anyway, half an hour later, I had my first apprenticeship. So and that was for Repco at the time.
Yep.
Repco was I think they had 50 manufacturing plants here at the time. So I got an apprenticeship at Hardy Spicer, who make a lot of driveline equipment for for agricultural and automotive industry. Anyway, so we went through that, and I did my tool making and started my diploma in mechanical engineering at the same time. They had a fantastic training facility at the time. I think we had 100 apprentices in a training facility.
And this is in Melbourne?
This is in Melbourne, yeah. And so we got through that, and then I went to I was in the factory, and we were fortunate we got shifted around to production and metrology, tool room maintenance, all these different places, so heat treatment, all sorts of stuff. So it was a really good background to start.
Yeah.
Anyway, when I got through my apprenticeship, they said, well, what do you want to do now? And I go, well, I don't know. I don't really like production that much, but so I'll go into maintenance. So I went into maintenance, and we started work on mechanical stuff, and then we had hydraulic machines. So I started pulling apart hydraulic machines. And in those days, we didn't have like all the AutoCAD to do all the manifold design. So I used to get cardboard boxes and templates, and I was making my own manifolds.
Yeah, right.
This is going back in those days. And, hence today we're making manifolds from you, but it's very different today with SolidWorks. And it's a whole lot easier.
Yeah.
So very shortly after that, I then went and did a diploma in fluid power for 5 years. And that started my my journey.
Yep.
I was fortunate enough, I worked for Rexroth at the time when I was part of the management group. They were the biggest hydraulics company in the world.
Oh, huge.
It was huge, yeah. So we got sent all around Australia fixing, all sorts of forestry, agricultural, industrial. So I was fortunate to have that background. And so that's where I've seen a lot of things that went wrong in that time.
Yep.
Yep.
And that's where you learn the most.
That's where I learned, yeah. So I stuck at that for about 5 years. And then I think I got a little bit frustrated and wanted to move on, because I was just seeing the same problems happen over and over, and I'm going, guys, this was mainly from a design point of view.
Yeah.
So I'm going, I think I can go, and with my knowledge now and my background, I can start to design different things. Yeah. And if I learned that I didn't think that as good as Rexroth was, I didn't think they had necessarily the best in everything. So there was Parker, and there was Eaton, and there was, Sun, and there was all these other companies. And so what I was able to do was to pick the best out of everything. Yeah. Yep. And I guess I've had a scientific mind, so I'm always drilling into the data. Yeah. How do I pick something that's going to make this system more efficient, work better, make it more reliable?
Yep.
And hence that started my journey. And so I did that for a while, and I was a national manager for other companies. I got to travel around the world to lots of different hydraulic manufacturing places. So I learnt a lot about the whole industry.
Yeah. And not just one industry.
Not just one industry. Yeah. So about 25 odd years ago, I just decided I would like to do that full time for myself. So I started HYDPOWER, and predominantly I had already been focusing on working with original equipment manufacturers around Australia. And there was a real need in that industry. Unfortunately, the industry itself doesn't really have a lot of design capability, and if you go to hose and fittings, it's even less, and then even less when you get to the manufacturers. Very few manufacturers had their own hydraulic specialist
We've got to
people.
rely on experts.
And that's okay. So I seen that opportunity in the market, and that's it. And it was really enjoyable. You could come to a place, or somebody would refer you to a place, and they go, and look, we've got this problem. We'd really like this to work better. And I'm going, okay, let's sit down, let's talk about it. And it was all about test and measure. And so, everything we do, I've got a saying, pressure gauges don't lie. It doesn't matter what you're doing. It all gets down to the work that's required by whatever equipment that you're working on. And then the rate of work will determine the power required to do that work. And then that all gets down to a flow and pressure. That all gets down to a control system. That all gets down to refining the losses that are in the system, whatever controls you need in the system. And you just take it from there, and then you put it on, and you test and measure, and you get a result, and then you refine, and then you select the right components.
You make it sound so easy.
It's like anything. I think if you do anything for long enough, and if you've got that mind, and if you test and measure,
and you're passionate.
And passionate. And, I'm a pretty proud, passionate Aussie guy, and I love coming to places like Griffith and that, where you see people like Daryl Serafin, who he's got a really good story to tell, and that your podcast guys.
A lot of the businesses in Australia, a lot of agricultural businesses particularly, do have a really good ground root story that come through. So
and I think Australians as a whole, we're a very fortunate country in one way, but I don't think it was all luck. If my experience of traveling around the country, and whether I'm working on agricultural or industrial or mining or whatever, the Aussie mentality is to try and keep progressing. It's very much like the Japanese philosophy in that
very
way.
Much so.
And when you drive around and you see some of the broadacre cropping and some of the other things that's happening, or we've done lots of work in grain elevation and dairy systems and sprayers. When you look at the equipment that we produce, or we get somebody else's equipment in and then we actually enhance it or refine it, it's incredible. And I don't know that it's still the case, but going back a few years ago, I know John Deere, whenever they were putting out something new, they would send it to the Australian market first and get the Australian market tested, because they knew that the Australians were going to push it.
Very much so. We have the same thing with the Brazilians.
Absolutely.
They send the stuff over to us all the time, and
sure. And I think we're good at refining. And
we're demanding. We demand a very good product. We have to, though.
Even if we look at what's happened here, so this cedar is a very good example of that, in my opinion. So I think I started work on that, I can't remember how many years ago. It might be 5, 7, 10, whatever. But you had a good base system. It just needed some refinement. And so what happened was we started a process like you would normally start. And I think at the time we were working on much smaller machines, much smaller flow rates. And of course, as what happens in the Australian way, it grows and it gets bigger and bigger and bigger and more refined. And I think that natural progression is a good thing. And I think it's part of what makes Australia what it is. And there's some really good mines and some really good people and some really good results we get out of agriculture. Well, and others, I'll say as well.
So with the projects that you've been working with us in regards to the Ultisow, you helped design the hydraulic valve block that we're using now. That was from a previous style that was pretty clunky. It was it did the job. But it was also a lot harder to be able to change between a standard manual adjustment to the electric and hydraulic and proportional.
So there are a number of things that come with that. I think the first part of it was that my initial request was, can we control the ground pressure more accurately than what we're controlling it now? And so when I looked at the way that we were, or that it was set up to control the ground pressure, and not just Seraphin, other manufacturers in the market, like most of the market, somebody had come up with a solution which was a reasonable solution using an accumulator system. And because what had to happen was we're asking to keep a constant ground pressure on a cylinder that needs to move backwards and forwards. And so what they would do is that they would charge up the system using the accumulators, or pre-charge the system using the accumulator. And then when the roller needed to lift up, it would push oil into the accumulator. And then when it came down the other side, the oil in the accumulator would just let the cylinder come down again. The only issue with that is, if you understand the way that accumulators work, when you push oil, you've got a nitrogen gas pressure on one side, let's just call it 50 bar if you like.
Yep.
And then when the pressure gets over 50 bar, when you turn it, it'll push oil into the accumulator, and then when it comes down, it'll push it out again. But when you push oil into the accumulator against the 50 bar of nitrogen, it actually increases the hydraulic pressure and the nitrogen pressure. It's just the way it works. So automatically, you've got a variation in pressure.
Yep.
Yeah. So I understood that wasn't necessarily the right way. What was a bit tricky was that there wasn't a whole lot of valves like we use now. So we use what we call a pressure reducing relieving valve. It has the ability to let oil in and out of the same valve.
Yep.
Yeah. And it made the accumulator redundant. We didn't actually need it anymore. We also then thought about that because you had a fan circuit that already had a constant supply of oil to it, we didn't have to keep topping up the system, because you've already got this constant supply sitting there. So I'm going, why don't we just use this constant supply, or part of this constant supply? The
because it's only a bit fairly small.
Fairly small amount, yeah. Well, it was at the time, because we were working on smaller machines, yeah. So on the smaller machines, it was fine just to have this constant supply of oil feeding the reducing relieving valve. So when we wanted to have some oil if a roller needed to go down, we'd just take oil of that system and it would keep it at constant pressure all the way down. And then when it needed to come up again, it would just actually let the oil back out.
Yeah.
Yeah. And so it was a very good result. And then we just went from that being a manual system to going, okay, how do we now have some sort of better control system so that we can, set for a certain amount of ground pressure, whether it was 400 PSI, 600, 800,000, whatever it happened to be. And at the time, it was a little bit clunky, because we had a pressure transducer that was registering pressure onto a display, and then we had a separate control that was controlling the pressure and electrical pressure going to the coil to the valve to control the pressure. And so we had done a lot of work in electronic control systems for controlling pressure and flow. So we worked with our American partners overseas to going, okay, we actually don't need to have a pressure transducer here anymore, because all we're really doing is converting that electrical signal from the pressure transducer to read something on a display.
Yeah.
And I'm going, okay, what about if we take the electrical current reading that's going to the proportional valve to the coil itself, and we just scale it to whatever we wanted, 0 to 100 or PSI or bar or whatever.
Yep.
So that's exactly what we did. So now we don't have a need for a pressure transducer, because the repeatability of the proportional reducing relieving valve is good enough.
Yep.
Yeah, it's within a couple of percent.
Yep.
And so that's where we went. So it simplified the system. We took one part out that was another potential part to go wrong.
That's right.
And made it more user-friendly.
Yeah.
And that's where we went to.
Yeah. So just working on optimizing what we already had.
Sure.
With new technology.
Yeah.
Yeah.
And I guess...
But also understanding what the challenges are.
What the challenges are, yeah. And, it's a more advanced strategy for sure, but it does get us a much better result in controlling the pressure, which is what we were setting out to do.
And you've also managed to do that at no greater cost.
Yes.
Really?
Yeah, that's right. Yeah, that's right. Yeah. So just better use of, deleting some components.
Yeah.
So my philosophy is, when I'm looking at how do we improve a system, is that we want, where we need complexity, we take that and we put the money into whatever that product needs to be. And if we can do that with the least number of components possible, the better. It's a less number of components we have to buy, purchase, and least number of components to go wrong.
Yeah.
Yeah. And hence the same as why we put everything into a manifold. We've got much less number of connections, less things to go wrong. Something that goes wrong, you screw a cartridge out, you screw another one in, and you're back up and running.
Yeah.
We also do most of our systems with manual override. So even if the electronics fail, we can actually still control the system mechanically. Yeah. And that's really important. If you're out and you're sewing and something, you run over your cable, you can actually still keep going on the manual system. Yeah.
That's right.
Yeah. And if you want to troubleshoot the system, you can set it up manually, or even when you're commissioning the system, you can do it. So it streamlines the whole process from concept to being out in the field.
Yep.
Yeah.
Yep. So you've done a bit of work with us. What are some other projects that you found as a real interesting sort of project where you sort of got hit with a problem and you've gone, you know what? I've got to really put my thinking cap on for this one.
On the industrial side, we did a machine for making 15 metre laminated beams, 200 cylinders on each, 10 beds. I think there was 250 cylinders total on the one machine. It was about as big as your showroom here.
Wow.
Yeah, I think there was 3,500 hydraulic connections on it. So there's sort of some of the sorts of things we get involved with. We've also done lots of work on grain elevation. We did a hydraulic drive, I think, where we had 600 tonnes an hour coming out of a hydraulic drive.
Wow.
And that was really good because on when it's harvest time, the trucks are coming in, they were all banking up, but they wanted to get back out in the field. So we went from, I think, taking about 10 minutes to unload a B double, got it down to 6. And so over a day, that was a lot of extra trucks out there, and the guys are happy, and the weather's coming, and you know the rest of the story.
Exactly right, like we're facing now.
Yeah. So it's been really wide and varied, and there's lots more stories. But
So as a small business owner in Australia, what's some of the challenges you faced?
I think there's lots of cost pressure in Australia. You know, we have a very high standard of living, and with that high standard of living comes high wages, high overheads. And so it's about trying to balance out what you can make locally and balancing out what you can buy from overseas. And, you know, whether that's, you have to pick what is best and relevant for whatever you're doing. So something that's going to work harder needs to be high quality. It's more likely to come out of Germany or the States or Europe. Something that doesn't need to work as hard or infrequently might come out of Asia. And then there's other parts, of course, that you can have made here. So I think that's the challenge. And I think that's the future of manufacturing for the country, unfortunately. I think
it is.
I think we're very good at refining equipment. And I think we should keep doing that more and more, just like we're doing here today, like we've been doing with your disc seeders. I think moving forward, it's probably the manufacturing side that we can afford to get in. And then if we can put our smarts on it, then I think that's the way that it's going to fly.
So you're talking about progression and things like that. Is that where the wall press come into it?
So I guess one of the other, being exposed to different industries for a long time, I probably went right almost back to the start of my career when I got asked to design hydraulic systems for wool presses because they weren't happy with them. They were too slow and too clunky and too noisy.
That's right. I think everybody that's worked in a bloody shearing shed and see how inefficient they
And it was really funny because it was always about cycle time. I could never quite understand it. You know, they just said, you got to get below 10 seconds.
That's right.
But, you know,
we talk about the trucks before. If you can change that cycle time, it's just a little bit quicker for them. Well, for the Rousey to keep going.
It's how much work you can get done in a day, you know. And it's not about the Rousey. Well, it's about the Rousey, but it's about the whole shed.
That's right. Because as soon as you slow that up,
everything else blows up. So
chain reaction.
So I had a long history in that, and I designed like a 3-stage hydraulic pump in there that had horsepower control, because one of the other big troubles they have is really poor voltage out on lots of the remote places.
That's right.
Around things, so they could get down to 180 volts. And single phase, the trouble is that single phase motors have capacitors and centrifugal switches inside the motor. And whoever originally designed that, they went for like a 2.2 kilowatt system, which was right, because you could plug into a 15 amp power point. Except the trouble was that they weren't using it at 2.2 kilowatts. They would load it up so it was really doing 3 kilowatts and overloading the whole system. And we'd have trip outs in the sheds, and we'd burn out motors in the middle of the day, and
that's right.
It caused a lot of stress and drama and stuff. So we did a lot. The machine I told you about for making laminated beams, that company is a very high level engineering company. They started doing a lot with variable speed drives. And then what happened was the variable drives have become programmable. As soon as they become programmable, it changed everything. You're no longer limited to anything. You've got a microprocessor. You could do anything. So we then started doing lots of hydraulic drives using variable speed drives with programs on them. So in that program, we could control current, flow, pressure, anything we liked.
Yeah. So when it needed a bit extra.
Yeah. And your bang for your buck was amazing. So you could, buy, say, a 3 kilowatt variable speed program for $500. What that you could do with that $500 was amazing. Yeah. Inputs, outputs, everything. Yeah. So what we started working on was a system where we could control the current, so that the program variable speed drive, we set up programs that we could control the current from anything from 10 amps to 20 amps just by having a pot on there. Similar to the pot that you've got on your dial, they've got a pot on their unit there. And if they've got poor power or low power that day, then it goes down. Because what happens in the electric motor is, again, it gets back to the basic physics. When the voltage goes down, the current goes up. It's inverse. Power equals volts times amps. So volts go down, amps go up, vice versa. So what it gives them the ability to do, instead of tripping everything out, it could just, we could manage whatever power they want. Nobody had been able to do that before. And so that was hugely successful. We've got about 150 of those systems out in the last 3 years, and the market's loving it. We then went to the next level and we put programmable touchscreen control over everything with remote control access. So now we can program anything that we like on there, and we can access it with mobile phone. You just got to sit your mobile phone beside the device. So you're out in some shearing shed, provided you've got a phone mobile connection, we can dial into it, we can monitor it, we can change the program, we can do whatever we like. That's a bit like Seraphim. Everything just keeps progressing. So then they go, okay, that's really good, but we've got this other problem that we want dual-sided operation. We want hydraulic pinner instead of corner pinning. Nothing meets the Australian safety standards. Nothing's Cat 3 certified that it needs to be. I'm going, okay. I'd worked with manufacturers for like 40 years, and I've gone, one day I want to make a machine. So I'm going,
something that I've got.
Some of this is my swan song. Maybe I can get the kids involved later, whatever. Smaller scale to what you guys are doing here. So we set out about 5 years ago in designing a whole complete brand new wool press, and
it's called.
It's called Woolmaster.
Woolmaster.
So woolmaster.com.au. But it's the only Cat 3 compliant machine that meets the Australian safety standards. And things are moving in that area. You've got like a 10-ton press that people are putting their arm into, and they're just pulling their arm out as it goes past. I say to the guys, there's a lot of resistance to, not putting guards on it or not making it meet Australian standards. But I said, if you put that into like a Woolworths or a Coles or Bunnings, it wouldn't get off the truck.
No, that's exactly right. Wool sheds used to be pretty agricultural, pretty dirty sort of places with hard working people, and that. Now they are some of the most restricted places on a farm where the shearers are drug tested just randomly. Workplace safety. Australia, they've really picked up that there is a lot of dangers in that environment, so they're really hammering on it.
So I think, in fairness, I look at particularly the broad acre part of the agriculture industry, and it loves technology, it embraces it, it does what you guys are doing here. The technology that's been in that area hasn't really shifted in 20 years. And the other problem that's happening is that it's becoming quite an old average age in that. And so they've got problems getting shearers and classes and presses. And so there's a real shift at the moment. We're working with the Shearing Contractors Association of Australia, and they're doing some really good work in education programming, making it safe. They're getting people from school on workplace programs, setting them up with training courses. And so we've now got a whole new generation of people coming into that industry.
That's right.
And there's we know we used to ride on the chutes back, and we might not anymore, but there's still a lot.
Still a lot out.
There's something like 38,000 farms in Australia that running sheep, and I think it's something like 18 million bales a year that still need to be pressed. We're 40% of the world's wool market. So, and like lots of things, we actually are good at what we're doing. Crossbred's made that a little bit harder now, where they wanted to get more meat, but unfortunately that then went against the wool, and the wool's not quality, so the wool's not worth much. It's much harder to press. The presses, the corner pinners that were originally designed, can't really press a 205 kilogram bale. And so it really, we come up with a hydraulic pinning machine, and it's about 30% faster. It only takes 5 loads to make one full bale, and it uses about 30 to 50% less power.
Yeah.
We can run off solar batteries, and so it's just a much smarter, safer way to actually do it. So we say faster, smarter, safer. Yeah, and that's what it is. And look, I think that's fair enough in an advanced modern society. I think, we can talk about, quad bike incidences and things, yeah? There's people being lamed and killed in mill presses as well. Not many, but, is 1 death acceptable? Is 5? Is 10?
That's right, but you still look at it and you go, for every one that probably does get hurt, how many hundreds of thousands have probably just pulled their arm out at the right time?
Yeah. So I think there'll be a shift towards a safer operation, and I think that's fair enough.
Well, I think it needs to. It's 2024, nearly 2025. It's the way, and to bring new people into the industry, you've got to make it safer.
Yeah. And there was a good analogy for it is that there's a thing called Evo system now, which is a safety cutout system for the shearing and not having overhead pulleys and stuff. Yeah, and that met a bit of resistance at the start, but it's just become the new acceptable practice. Yeah. And so our machine's probably a bit like comparing like an old HQ Holden to a new Tesla. That's where we're at with it. But like lots of things, like you're trying to do, we're not trying to make it difficult. We're actually trying to make it better. So we're not just going, okay, you guys need to catch up and put safety guards on and meet Australian standards and whatever. We're saying, okay, you've got all these benefits in its productivity, 30% faster, 30% less power. There's a huge push to have less power.
Like you said, when you're out on the farm, the power's not great anyway sometimes.
Yeah. So that's where we come from. And so we've had some really good feedback on that. We've got a few out in some more stores out at the moment. And people are really happy.
30 years ago, we were talking about flying cars. Now we've got bloody ball presses that are remote control from your phone.
Yeah, absolutely.
Finishing up with some advice in hydraulics.
Yeah.
Just for the end users out there. A lot of people are going to be listening to this are going to be end users, not so much the manufacturers, but end user information just as a bit of a...
It's a really good question. I guess if you spend long enough in one industry, then people will come to you and go, what's your thoughts on this or that or the other? Or I get a lot of people come and say, can you teach me about hydraulics? Sure, I could. How much time have you got?
That's right.
So can you teach me in a day? So can I teach you what I've learned in 40 years in a day? No, I probably can't. But it's a very good question that you ask. So I'm proud and passionate about hydraulics, and I'm proud and passionate about making all the systems safe and reliable and having longevity. And hydraulics, like lots of engineering, and there's a lot of science to it. And I think you have to follow the science, and you have to work within the guidelines of whatever that science happens to be for whatever industry you're working in. It wouldn't matter if you're on mechanical, like what size bushes should you have, or what should your hardness of your steel being, or whatever it needs to be. So my advice to people with hydraulics is that you probably shouldn't overwork it too hard. I would use it within probably 75% of its capacity. And you'll get better life out of it that way. But one of the biggest reasons why hydraulic systems fail is contamination. Unfortunately, if you look at hydraulics, if we took hydraulic motor just as a guide, if you looked at a 10 kilowatt hydraulic motor, we could have something that's probably weighs 5 kilograms and it's maybe 100 mil square. If you were to look at an electric motor of the same size, it's probably going to be 300 by 500 by 300, and it's going to weigh 30 or 40 kilos. So the power to weight ratio between an electric drive, if you like, and a hydraulic drive, it's significantly less in a hydraulic drive. As a result of that, what happens is, in my opinion, is that the tolerancing and the finishes and the quality of materials become much more important. What goes with that was and it's very well documented now, that if you have even a small amount of contamination in there, it will accelerate the wear of that disproportionately. So even a small amount of contamination in the system is enough to do it, because when you introduce a smaller part, when it goes through pumps and motors and things, it actually takes off more and creates it like a cancer. Yeah. So, and then those parts get caught in cylinder rods and seals, and the whole thing starts to break down. Yeah. So the real answer is never to get it in the first place.
Yeah. Stop the contamination rather than trying to filter it.
And there's two sides of that, and I was speaking to your guys about the day. The first side is that when you're doing your initial assembly, it's really important that everything is kept clean and plugged up. So a lot of what goes on to hydraulics is in fabricators. So you've got grinders and dust and metal. It's really important everything's sealed up.
Yep.
Really important that you projectile clean all your hoses and your tubes, and that you just connect everything. Because once it's sealed, hydraulics is pressurized from the inside out. So outside contaminants can't really get in, unless you put them in from the start or you introduce them later.
Yeah.
In the ag sector, where it gets particularly hard is where you've got quick release couplings. Yeah. Fantastic thing as a power source. Just plug it in.
Plug it in and go. That's why mine's don't.
Yeah, how good's this? I got all this power available and I can do it remote, and I can add 10 implements out the back, and everything's fantastic. So the only thing I'll say with that is that anytime you're going to connect those quick release couplings, you need to have a rag and you need to have a can of degreaser in your tractor. Yeah. And wipe off the male part, the female part, open up the thing, give it a spray with a degreaser, make sure there's nothing in it before you click it in.
Yeah.
That's the best advice I can give you.
And it's easy.
And it's easy. And you can avoid a really expensive repair, because once contaminants are inside that system, you basically have to pull that whole system apart and start from scratch. Yeah. And you could extend the life of your machine tenfold just by doing that. Yeah. So that would be my advice. The other bit of advice I would give is that it's like your car service. One of the things I don't actually understand about a lot of people who have hydraulic equipment, they don't seem to worry about the service. Yeah. So you wouldn't go and buy a brand new car and go, I'll just drive it for 5 years and, then I'll give it a service. No, every 1,000 Ks or every 5,000, 10,000 Ks, 12 months, you give it a service. Yeah. Give your machine the service once a year. And if you do that, if provided the machine's been designed correctly in the first place, then do it. If you've got something overheating or something you don't think is quite right, I would suggest that you get in touch with somebody like myself or a hydraulics expert and go, could you just have a look at this for me and just, give me an opinion on what's happening. Yeah. Yeah.
Because sometimes it could be just as simple as changing a hose size.
Yeah, absolutely. And what people don't realize about the filters is that all the hydraulic filters got bypass. Yeah. So once they become full and clogged, they just bypass. So you're no longer filtering anymore. Yeah.
And they also put in just another restriction in the system.
In the system as well. Yeah. Yeah, absolutely.
So you get potential different, losses and things like that.
That's right. Yeah. Yeah.
I always thought that just filter it out, it would be right.
Yeah. Yeah. No, it's. So keep it cool.
That's why you're the expert.
Yeah. Keep it cool, keep it clean.
Yep.
Yeah.
And only use it about 75% max capacity, and it's going to last.
It's going to last. Yeah. Yeah. So that would be my advice.
Excellent, mate. Yeah. I really appreciate it. Yeah. Well, thanks very much for your time.
Yeah.
Really appreciate it. It's been great working with you, and I think we have got plenty more that we can be working on going forward as well. Always looking at the future and what else is there, and everybody's needs are changing.
They are.
So while people's needs are changing, we're always going to be looking for expert advice. So thanks for your
probably just finished. And I think one of the things that is happening generally across the industry, and particularly in Australia, and particularly in agricultural, things are getting bigger and bigger. Tractors are getting bigger. If we went back 30 years ago, they used to have a fixed gear pump. It was 10 gallons a minute at 2,000 psi. Yep. Yeah. So 10 gallons a minute, it's 40 litres a minute, at 140 bar. These days, your bigger 600 horsepower tractors, they could be up to 140 litres a minute and 3,500 psi. Yeah. Yeah. So what's happening is everything seems to be getting bigger and bigger to increase the efficiencies of the farming, get the cost down, whatever. Yeah. Yeah. So that's where I see it going. So with that, I'd just be mindful as things get bigger and bigger, your hydraulic systems need to evolve with it as well. So, if we go back to the Seraphim story, we started with a fairly basic system designed for 60 litres a minute. We're now working on 120 litres a minute. Yep. I don't know, in 3 years' time, we might be working on 200 litres a minute. I don't know.
That's right.
But in all probability,
you've always got to keep moving forward. Because as soon as you stop, you're in trouble.
That's it. Yeah.
Fantastic, mate. Yeah. All the best with the Wool Master. I think that's going to be fantastic for the Australian industry. Yeah. It's good because, like I said, it's going to, if you can make things safer,
Yeah.
it's going to draw more people.
What's safer and
industry and
faster
stuff.
and more efficient? That's
That's
what
right.
it's all about.
Yeah.
No different than what you guys are doing here.
Yeah.
Yeah.
Fantastic.
Yeah.
Excellent. Thanks very
No
much
worries.
for your time,
Thanks,
mate.
Rodney.
Really
Yeah.
appreciate it.
Terrific.
Thanks, everybody. We'll call it a day.
Yeah.
And like and subscribe to the podcast. That way, then you can keep up to date. Woolmaster.com.au for the wool press, HYDPOWER.
.com.au.
Yep. For your hydraulics. So if you do happen to have a problem out there in regards to, like you said, overheating oil or inefficiency somewhere, whether you're a manufacturer or that, perfect opportunity to give yourself a call.
Yeah, sure. No worries.
Excellent. Thanks, everybody. We'll catch you later.
Thank you.